Okay, so let's talk about the important principles that we will definitely use now as we solve problems in statics. So the first one is law of transmissibility. Now, you have to understand that in order for you to understand this principle, there are two primary elements that you need to monitor. The first is the actual location of the force, and then the line of action, the actual location and then its line of action. So as you can see, when we say line of action, it is simply the path, or it is simply the line that the force is passing through. So for example, on the figure, so this is the line of action of force F. And then let us say that the magnitude is 200 kilonewton. Okay? So when we say principle of transmissibility or law of transmissibility, we can adjust the location of the force anywhere, no, anywhere, um, uh, anywhere on the object or anywhere on the body. Okay, as long as the force is passing through its line of action. So the magnitude of the force involved remains constant. Hindi siya nagbabago. Hindi siya mako-compromise. So let's say that the magnitude of the force is 200 kilonewton and then it is placed on the left side of the object. Okay, so we can also put it, okay, at the center of the object. Okay, without compromising its magnitude, so the value remains 200 kilonewton pa rin. Or we can also change its location and then place it on the right side of the object. So the magnitude remains 200 kilonewton. So that's law of transmissibility. So this is actually one of the effective principles that we can utilize if we are computing moment of forces. Okay? So this is the best principle that we can use. Usually kasi ang pinakamahirap doon, yung rotation, analyzing the rotation, if it is clockwise or counterclockwise. So this is the best approach that we can use. Anyway, so let us proceed in analyzing an inclined force. So it is customary kasi that the easiest orientation of the force is horizontal and then vertical. Okay, so paano kapag naka-encounter tayo ng inclined force? So for example, what we have on the figure is we have an inclined force that is acting northeast. So the best way to analyze it is to actually split it into its components. So this will be subdivided into two components. So the first is horizontal and then the second is vertical. So definitely the horizontal component of the actual inclined force that we have here is eastward, and then its vertical component is upward. So we can also describe this as the x component aside from horizontal component, and then we can also call this one as the y component or vertical component. Okay? Now, probably most of you are asking, Sir, what are the basic processes that we can use to compute the components of an inclined force? So we have actually two approaches, no, depending on the orientation of the distance given. Okay, so for example, let us proceed to the first approach if the distance specified is an angular distance in terms of angle siya. So as you can see, there are two possible angular distance. Okay, the first is the angular direction of inclined force measured from the horizontal. Let us name this as theta. And then the other angular distance is if it is measured from the vertical line. Okay, so paano ang pagkuha ng x and then y components kapag in terms of angular distance? So focus na muna tayo, halimbawa, we have theta for example. Theta ang given angular distance, and then remember that it is measured from the x-axis. Okay, now paano kunin yung x and then y component kapag ito yung given angular distance? So what we need to apply here is to use offset method. And I believe that everyone is already familiar to this method, which we call offset. So when we say offset, we will basically copy the graphical orientation of the force anywhere as long as it is parallel to its original orientation. So pwede natin siyang ilagay sa kahit saan. So for example, I want to offset the y component. So instead of the left side, I want it to put on the right side. Okay? So another important thing about offset method is that once we already offset the graphical orientation of the force, we will not also compromise the magnitude. So the magnitude of the force remains the same. Okay, so this is still Fy. Okay, now the reason why we applied offset method is that we can analyze this as a right triangle. So tanggalin na natin yung original position ng y component na nasa left side. Focus tayo dito sa right triangle na meron tayo. Now, since this is a right triangle, so meaning to say, the appropriate approach in computing the components is the theorems of trigonometry. SOHCAHTOA. Now, particularly SOHCAHTOA because the specific type of triangle is a right triangle. Now, say for instance, I want to compute the y component of the inclined force F. So this is the opposite side of theta. And then take note that the magnitude of the hypotenuse side of the triangle is also equivalent to the inclined force F. So since this is opposite, this is hypotenuse, what the specific trig function that we can use is sine function. So sine theta is equal to the opposite over hypotenuse. Okay, so therefore by applying cross multiplication, we will be having the equation in computing the y component. Now, next is if we want to compute the x component. So this time, the horizontal side of the triangle is adjacent to theta, and then ganun pa rin i-correlate natin siya doon sa hypotenuse side. So cosine function. So by using cosine function, so cosine theta is equivalent to the adjacent side, which is fx, over the hypotenuse side, which is f. So by again applying cross multiplication, we will be having the equation in computing the x component. So these are the two formulas that we can use in computing the x and then the y components if the angular distance is measured from the vertical axis. Now, paano naman kapag yung angular distance measured from the vertical? Okay, ulitin ko yung statement ko kanina. So these are again the approaches that we can use if the angular distance is measured from the horizontal. Now, paano naman kapag yung angle ay measured from the vertical, which is beta? So ganun pa rin. So apply tayo ng offset method, but this time it is not anymore strategic to adjust the y component. The more strategic is to apply offset method to the x component. So instead of its actual location, offset natin siya dito sa taas, tapos disregard na natin ito. So again, we did not compromise its magnitude. So its magnitude remains constant, okay, or still the same. Now, if we want to compute this time the y component, so based on by basing on the angular distance, yung Fy is adjacent to beta. Okay? And then let us try to correlate it to the hypotenuse side of the triangle. So which is the inclined force F. So cosine function kasi adjacent hypotenuse. So by using cosine function, so cosine beta is equal to the adjacent side, which is Fy, over the hypotenuse side, which is F. So by applying cross multiplication, we will be having the equation in computing Fy. And then if we want to correlate naman the opposite side of the triangle and then the hypotenuse side, sine function naman. Okay, so therefore sine beta is equal to the opposite side Fy, rather Fx over the hypotenuse, which is F. So by applying cross multiplication, so we will be having the equation in computing the x component of the force. So kung napansin nyo, nagbaliktad yung trigonometric functions, no? Nung previous angular distance natin. Kanina yung y component, ang trigo function na involved ay sine. Pero dito, ang trigo function na involved na ay cosine. And then dito naman sa x component, the trigo function is cosine. And then pagdating dito, sine. So basically, yun yung nakakalitong part. That is why I am suggesting you that instead of memorizing the formula, what you need to actually do is to understand the principle. Now, so this is the approach, no, in computing the components by referring to angular distance. Now, the second approach is if the given direction is in terms of slope. Okay? Okay. So when we say slope, the rise and then run. Okay?